Hello and welcome to another episode of the AI Show. How's it going? It's Friday, or shall I say, Friday. Yeah. No, do not like that. I'm pretty excited to be here. It is Friday, August 26th, and we have an amazing show for you today. I'll tell you about it. But first, where is everybody coming to us from? Let's see. Ivana, welcome. Good vibes indeed. Brasileiro. Eu posso falar português também se quero. That's not true. So I took French for many years, and I know how to speak Spanish. And Portuguese is just like right in between. It's great. Kevin, it's good to see you, buddy. Thanks for coming. I got this. Yes, I do. We're going to do this. We're going to get things to work today. I promised I'd look, because I didn't get things to work all the way last time, and I told you I would look into it. And so I did. I did on the AI side. So we're gonna do more AI side stuff. Which reminds me. Let's get our pandemic purchase here out. My Wacom. My Wacom tablet. I don't know, should I have the whole thing like I'm in a hall the whole time? I feel like, I don't know, like I'm in a cave or something. Do we want to do that? I don't know if we want to do that. Let's turn this on here to tell you what we got going on today. Touch is on. Number one today, computer vision plus OCR with Carlotta and Bethany. They are in Italy and Nigeria respectively, and so I pre-recorded it, and then we get to watch it. My audio is not as good, but I thought, you know what? It doesn't matter what I say. You know? It only matters what they say. And then number two, more Rochambeau. We're going to have plenty of time. Remember, when I did this last time, my experiment was failing. Today we're going to investigate why that's the case and how to fix it, which I'm pretty excited about. So, and also, I got a new light. Boom. Huh? On or off? On or off? What do you think? On or off? Wait, hold on. Let me go full screen here. On or off? On. Off. On. Off. I mean, what are we thinking? Kevin saying on. But then it feels like we're in a CD bar. And everyone's like, but yeah, this is Seth. This is a CD show. So I think it works. On. Great title. Yeah, today we are going to be just doing some cool stuff. OCR, computer vision. What else we got going on here? Yeah, .NET app. This will work in your .NET apps. 100%. Beautiful day indeed. I have never met a Nigerian I didn't like. I used to live in Spain. There was a lot of nicest, wonderfulest people. Kenya as well. I was in Kenya about like 3 or 4 years ago. Probably one of my most favoritist trips in the universe. You know, I really haven't gone anywhere in like 2 years. Anybody have that problem too? Hello, Dario. That sounds like a Spanish name. Bienvenido. Okay, so I'm gonna leave the light on because that's what people do with that. All right, and then also I thought, because there is some delay between when I talk to you and then you answer, is I wanted you to get some questions in there over what we're doing. Just get them in there. I'm here to answer your questions. I'm here for you all. So please be aware of that. I'm here for you. We are here for you. All right, so let's start first with our wonderful interview that we had with Carlotta and Bethany. So I'm going to turn that on right now, and then let's answer any questions right after. You're not going to miss this episode of the AI Show where we talk about applied AI, computer vision, and OCR. Make sure you tune. Hello and welcome to this episode of the AI Show where we're talking about applied AI, computer vision, and optical character recognition. Let's start with introductions. My friends, welcome. Tell us who you are and what you do. We'll start with you, Carlotta.
Yeah, hi everyone. So I'm Carlotta, I'm based in Italy, and I'm a cloud developer advocate at Microsoft, focused on AI machine learning technologies, and I'm thrilled to be here today.
Fantastic. Bethany.
Hi everyone, I'm Bethany Jepchumba from Nairobi, Kenya. I work with Carlotta as a cloud advocate for AI and machine learning, and I'm also thrilled to be here.
Fantastic. So why don't you explain what all of this is all about? Bethany, we'll go to you, my friend.
So today we're talking about computer vision, and this is a subset of AI that deals with giving applications the ability to see the world and be able to make sense of it, turning it into either readable or audible experiences. So as you can see in the image on the right, AI sees an image as a group of pixels values, and it can be able to interpret it, giving you an idea of what exactly is in the image. So it can do things like analyze your image, recognize text, that is what we're talking about in OCR, optical character recognition, and finally detect the different objects in an image.
So it's basically anything having to do with pictures and getting computers to do something with it. Am I right?
Yeah, you can also add videos to the mix.
Oh, see, I kind of knew this, but I feel like there's a ton of value here with what people can do. But can you give us, like, in practice, what are some things that one can do today?
So for example, using the Azure Cognitive Service, computer vision service, you don't even need to write any line of code, but you can use the API to do things like detect images in objects. There's this app called the Seeing AI, and the application actually reads out loud what is in the environment, and people who are not able to see can be able to get audible experiences of what is going on in the environment.
I love it. Is there a way that we can take a look at what this looks like in action? Carlotta, can you help us out with that?
Sure, of course. So I would like to show you a short demo in a way to guide you on how you can integrate in your solution computer vision service. And in particular, I'm going to show you how you can integrate the computer vision service in a React static web app, which will call the service using a URL of an image typed from the user as input. And also I will show you how to deploy it on the cloud. So as prerequisites of this demo, you will need two types of Azure resources, a cognitive service resource type, which we will need to consume the service, and a static web app resource, which is a service that automatically builds and deploys full stack web apps to Azure from a GitHub code repository each time you push commits or accept pull requests in a branch of your choice. But
this is awesome.
Yeah, sorry. But let's go maybe into the code itself. I have it in my Visual Studio Code environment, and the functionality which calls the computer vision APIs is hosted in a separate file. So you can see here a JS file in which at the bottom we start with configuring the key and the endpoint, which are the parameters used to consume the computer vision service. And then the visual features we are going to use to call the service as well. And scrolling down, you can see the main function of this JS file, which is the computer vision function. This function performs a few tasks. For example, it initializes the client using the key and endpoint previously set. Then it initializes the URL of the image we're going to analyze. and it is going to call the Analyze Image API using the visual features and URL we defined before, the computer vision client, of course, and the Analyze Image of the computer vision SDK for JavaScript. And in addition to these, if our image that we want to analyze contains text, check that we do by checking if in the return list of tags we have the handwriting or text tags. In this case, we are going also to call the read text from URL function, which is going to call the read API of the computer vision service function, which has optical character recognition capabilities. So it is able to extract text from the image. But I also would like to show you how you can, when you have this function defined in a separate JS file, how you can integrate in your React Static Web App the service. In a few lines of code, you can call the computer vision function we just you just see in the other file and reset the state of the app. And we also are going to display the results of the computer vision service on our application by converting the results from a JSON format to a readable format. So once you have all these things set up, the next next step is, of course, running the app. And the best practice is running the app locally, and then if everything works fine, deploying it on the cloud. But for time constraints today, I'm going to show you directly how you can deploy this app on the cloud. So we are going to trust this code. And in order for our app to retrieve the key and endpoint of the service, we are going to add a pair of lines of code which tells to our app that the parameters, the key and endpoints parameters, can be retrieved from the secrets of our GitHub repository, in particular in the actions action section. So I've already set up these secrets for you. So I'm just going to add in the workflow file, in the YAML file of the workflow GitHub workflow file, I'm going to add this pair of line of codes here to tell our app that it can retrieve the key and endpoint starting from the secrets of the GitHub repository. And then we can just commit and push these changes because, as I told you before, by pushing to the main, in this case, to the main branch, these edits, we are going to launch a workflow. So we are going to run a workflow which will finally deploy the app on the cloud. So I'm going to, for example, write here, add secrets to actions as a commit message, and I'm going to commit and push these changes here, and I will show you how these result in a here we are. This is my GitHub repository. So this results in a workflow running here and deploying the app on Azure. So now I will hand over again to Bethany, I guess, in order to show us this app running on the cloud and the computer vision response to our image.
Just a couple of questions before you go. This is awesome. So basically, if I'm understanding right, this is all a client-side React static web app. It's just a demonstration on how to get it started really quickly with the API. That then you put the keys into GitHub Action and then pushes it to Azure static web apps. Am I getting this right?
Yeah, it's perfect. Definitely, yeah.
Fantastic. And then the other question I have is, generally it's not good practice to put the keys in the client side, but this is just an example. For those that are watching, you generally want to put that part in the back end in the function. Is that right? Am I understanding that right?
Yeah, of course, it's right. This is a very simple example just to like familiarize with a computer vision integration in your solution, but definitely this is the right way to do things. Yeah.
I love it. And that's the cool thing about JavaScript, right? If it's in the background or the front end, it kind of looks the same. So really good example. Bethany, you're going to show us this in action. Is that right?
Yeah, that's something I'm going to do in a few. So I'll use this image and I'll copy the image link, go to our tab and enter the URL. Once I enter the URL here, it will go ahead and analyze. While it's analyzing, there are 4 key things I'm going to show you. The first one is the color aspect of it. So as you can see, it's given me the URL and the different categories it belongs to, but I want to focus first on the color. So on the color, it gives me 3 major things. Number 1, it gives me an idea of whether the color is either a black and white image or not. In our case, it is not. The other thing is the dominant foreground color and the dominant background color, as well as the accent color. And as you can see, it gives you an idea of if you want to build an app with this color code, it gives you an idea what color scheme to follow. The second one is tags. Tags give you an idea of what are the contents of the image. So the tags here are text, it's a font, it's a circle, there's a couple of logos, the clip arts, graphic design. So it's just giving you random things that can be used to describe the image. The third one is the caption and the description of the image. So the description here is this is a diagram and the confidence level is not that high. So it's telling us, yes, this is a diagram, but of course there's so many things around it. It's not just a diagram. And the last part is OCR, being able to recognize the text here. And the text, as you can see, is make things happen. So how are you able to recognize the text? Let's see from our results. And the first one here, as you can see, the model version, this is the text and it's reading the results. It's giving us a bounding box on where they are. And the first one is the text make, and this is like the location of the text, and the confidence level is 96%. That is very high. And then coming down here, it's the text things, giving us the location of it, and also the confidence level is about 93%. And the last word is happen, this is the location of the word, and it even has a higher confidence level. So that's it about being able to detect the image and figure out what are the texts there, what tags can you associate with the image, and so on. Yeah.
And this is cool because this isn't the first time I've seen these, but every time I see the results of calling a cognitive service, it's amazing from design, you showed us the colors, to the text that's in there, to any tags that might be associated. It's just, there's so much information that you can get just by calling a service. And I think it's really cool, Bethany.
Yeah, so many. This is just like scraping the surface on what you can do. There's so many other things in case you want like detect if this is a famous person. There's also a service, a tag for that. So yeah.
That's really cool. Just a side story, since we're all here. I was on stage with a guy that was famous, and I was showing this service off, and I made fun of the fact that it recognized him but not me. And so I guess the devs were watching, and so now I'm a famous person for cognitive services.
You should talk to the cognitive service team.
Isn't that cool? No, if you put a picture of me, it recognizes me because I made fun of the devs and they got me back by making me AI famous. I'm so happy.
Can you link me up to the devs?
Yeah, I should send you. It's really funny. And because I try to make that joke every year at a conference and it stopped working. And they're like, we got you, Seth. So it's actually really cool, the amount of people that it recognizes, the amount of information you get from design to whatever. But in all seriousness, there's so much to learn in this space. Is there, like, if let's just say someone's watching and they're a beginner, what would you suggest that they should do? Carlotta, we'll go to you.
Yeah, so we have a wonderful curricula actually for beginners, for AI beginners. And for example, if you want to learn more about the behind the scenes of this computer vision service, so which algorithms are behind the scenes of this service, how these algorithms, so we are talking about neural networks, deep learning, how these algorithms work and how they can see the world. So if you are interested in these kind of topics, definitely look at these beginners for AI for beginners curricula.
Fantastic. And I'm going to put the link below. It's just, if you go to aka.ms AI for Beginners repo, it has, I think it has lessons, it has explanations, it has really cool diagrams. Am I getting this right?
Yeah, right. Yeah, it's divided in different lessons, so it's very useful also if you want to like use it as on your own, let's say, to learn it on your own.
Fantastic. So for those that want more of a lesson guided something, is there something like that for them?
Yeah, of course. So as Bethany just said, we just scraped the surface of what of the capabilities of computer vision services, but there are more. And if you want to learn more, there is a learning path for Microsoft Learn dedicated to computer vision service. So definitely you should catch it up.
And then the last thing, we'll go to you, Bethany. Is this code that you showed, is it available somewhere?
Yeah, there's a link also that we shared, and you can go to that link and get access to the code and play around with it, see if you can make our UI better. So, yeah.
I think when it comes to UI, I am the worst, and so I will not be able to help you, but maybe some enterprising youths that do AI will be able to do that. Thank you so much for spending some time with me, my friends.
Thank you very much.
All right, we've been learning all about applied AI, computer vision, and optical character recognition here on the AI Show. Thanks for watching, and hopefully we'll see you next time. Take care. How about them apples? Wasn't that cool? All right. They were so delightful to have. And we recorded this early in the morning because Bethany's in Kenya and Carlotta is in Italy, and I did not want to keep them up. All right, so some questions here. Let's get to it. Question: which deep learning architecture is used in your solution? Thank you. It turns out that we're using a lot of them, right? Because notice that there's text extraction, there's celebrity recognition, there is also part of the API that tells you whether something is racy or not. For example, it's really useful if someone's submitting a picture to a forum that you have online and you want to make sure that everything is PG-13. You could totally get a score from that. So it's actually a bunch of models, not just one. And so I couldn't tell you all of them. So that's a really good question, Jose. Thank you so much. Janiscu number 7. Hold on, we got to. Janiscu number 7. I don't know why it's not sounding right. This doesn't sound the way I like it. All right. Thank you. As he often does in his way. Briefly. This is cool. Indeed, it is cool. Before, I thought computer vision and machine learning were the same thing. Yeah, and Mario, you are not alone. Machine learning has received hype over and over and over again. I mean, in the 90s, there was a hype over AI, artificial intelligence, that kind of petered out. And so it's easy to get confused with this stuff because no one's very clear. But I think, like you said, computer vision is like machine learning applied to image recognition. Exactly. And to video and anything having to do with this. So yeah, absolutely. So is face recognition similar technique? Yeah. Imagine being able to project using machine learning the picture of a face into vector space and then a picture of another face into vector space and then measuring the difference of those two vectors. And if it's close enough, and then you train a machine learning algorithm to optimize those parameters, you can do that. I think it's called the twin model something. I don't remember, but I'll have to. I don't remember. I want to learn more about AI algorithms. Me too. In fact, we're going to be doing one today. We're going to be doing one today. Thank you, Jose. Indeed, they're pretty awesome. Maybe we'll even take a little detour and see if I'm still famous according to our Microsoft AI. Do I need to master linear algebra and statistics to become an AI ML engineer? No, you do not. So the way I like to think about it, and then maybe those of you that are smarter than me can correct me in the chat, is that there is the data science role, and then there is the machine learning engineer role. The data scientist's job is to create models that work. The ML engineer's job is to take those models and put them into production. Now, sometimes these jobs are conflated, but you could be one of either, right? You don't need to know linear algebra to know that this particular machine learning model takes a vector of a certain size, and then out comes a vector of this size, and this is how you interpret it. You don't have to know linear algebra to do that. For some cases, you don't even have to know linear algebra to be a data scientist, although it's helpful to know what's going on. Like if your algorithm is producing not a numbers, there's something going on with your machine learning algorithm. Okay, so let's get my screen back up here, and let's see. I thought we would look at the portal here. Let me get the portal up here because I wanted to see if I was still famous. Portal.azure.com. Another question is, will you do a more advanced show on OCR? Sure, absolutely. So I want to get this one up. So more advanced show on OCR? Absolutely. Why not? I love that. We should take note of that. Peggy, our wonderful producer in the back end helping. She's awesome, by the way. We should give Peggy a round of applause for being just a wonderful, thank you, wonderful producer. It's just, I mean, there's not enough clapping or air horns we could do. Thank you. Yeah, we'll take that down. We should totally do another OCR, an OCR episode. Okay. Oh yeah, my dream is to be with you, Mario, doing AI stuff. And you don't even have to work for Microsoft. You could build your own AI empire. And I could go be, I could set up chairs, do whatever we need to make that happen. Let me zoom in here because I'm realizing that it's hard to see stuff. Okay, so let me go to Cerebras. This is what I called my cognitive service multi-service account. Let me lower the music here. I wanted to see if I was still famous. So let's see. We are doing vision. Custom vision. No, not custom vision. Computer vision. Nice. About image. Oh! See, I heard about this. We have new studios, and I set one up beforehand, and I already have my resource set up. So let's just see. Detect. What do I want to do? Extract text from images. Detect faces in an image. Let's try this out. In order to run this demo, this resource must belong to East US. Well, we don't want that. Let me see. No face featured. Recognize a particular person. Yeah, so many tools. It's true. Extract common tags. Why do I need to be in East US? Choose a different resource. No, I'm in West US. Choose your language. Browse. Let me get my Twitter photo here. Twitter. This is Twitter. There's me. Open image in new tab. Save image as desktop. Hey, I already have a headshot. So I'll just use that one. I don't think it's going to let me do it, though, because it's not in East US, which is weird to me. I'm going to have to ask him why. Please acknowledge. Why won't it let me do it in East US? I wonder. Let me see here. I wonder if I can move this into a different location, which is weird to me. Let me do this. Let me create a resource here, and we're going to do cognitive services. Cognitive services APIs. Is it APIs? What's the difference between cognitive services, APIs? Cognitive services. Ah. Ooh. Bundle. Create. Avi, we want this in East US. And we're going to put it in our Vision one. And we're going to call this Eastern Eye. Boom. Pricing tier standard S0. Boop. Boop. Okay. Next. Status. Enable system assigned identity grant resource access to other existing. Oh, hey. This is interesting. I haven't done a cognitive service thing in a long time. So this is kind of cool. Take a little detour here. By clicking, I agree to the legal terms and privacy statement associated with the marketplace. Is it a marketplace offering? I don't understand. This is a marketplace app? I don't want that. Cognitive services, APIs. That's by Microsoft. Okay, I almost got bamboozled. Uh-oh, something's broken. Something's broken. Oh no. Maybe. Oh, because it's preview. Okay, let me use the one that actually works. Create a resource here. Cognitive services. So this says Microsoft. So I was being a fool. We're gonna put it in Vision, East US, and then we're gonna call it our Eastern Eye. Eastern Eye. Pricing tier S0. Yes. So I'm gonna tell you all, when you're looking at this stuff and you're like, oh, something doesn't work, it's because I'm usually using pre-release stuff. Shh. Oh, my deployment is complete. All right, so let's go to the Vision Studio and let's choose a different resource. Refresh, please. Refreshings. Look how many resource groups I have access to. One day they're going to find out. They're going to be like, we have given Seth way too much access. They're going to be like, what if he goes in there and uses it? Yeah, it's true. I will use it. I will indeed use it. By the way, I like now that my face is down at the, so it looks like I'm looking at the screen now. Oh, look at that ginormous box of select an Azure resource. Eastern Eye, confirm. Boom. Okay, let's do it. Human face. Mustache. Look at that. I have a not just a beard, but a mustache. My necktie is 55% on point, and my suit as well. Let's take a look at the JSON. So these are the tags, etc. I wonder if I could go to computer vision. Let's see what else we got. Detect faces in an image. Unimage. Oh, there's my face. There it is. I gotta see if it thinks I'm famous. That's what we're here for. Okay. We're here to oh, here we go. Try it out. We're gonna identify Seth Juarez. Don't say it like that. It's Juarez, or as Americans would say it, Juarez. Okay, open. Oh, I see. Provide one or more samples of your own face. No, I don't want to do that. Now, here's the thing also. Like, these things could be used for ill. Don't use these for ill. We have strict requirements over some of these things, so I wonder why it doesn't face. We don't face image analysis. Let's try this one. Let's try this one. Person, Jason. Oh, there's a way to make it use REST API. Here we go. Here we go. Analyze image. Analyze image. And then we want to put the image in here. Example. Oh, cool. Look at that. I could just do this. I could just do that. Let's make a phone. Let's make a call here. I wonder if there's a place where I can put it though. Satya Nadella sitting on a bench. Okay, but there's got to be a place where I can like try it. Ugh, you know, I just got in Spanish, the word is flojera, the lazies. It's like I don't want to do a REST call because, nobody got time for that, Like, literally, the name of the call is REST. Okay. I wonder why I can't just use the Vision Studio and say, hey, do more stuff. Documentación. Recognize a particular person. Compare faces. No. Look at that. That's the wrong one. How is everyone going to know that I'm famous? Fake famous, actually. Fake famous. Okay, let's try this one. Oh, jeez. It's blocked. Comparación de caras. Así es. Yeah, it looks like I have to wait for this one. Let's try this. Oh, it's still setting up the thing. Que fuerte. Vision Studio, what else? Extract text from images. This is everything, right? Optical character recognition, spatial analysis. Oh, this is cool. Image analysis. Oh, I think the reason why this one didn't work is because it's in preview. Detect common objects in images. Let's try this one. Yeah. Look at that. It found a person and a tie. I guess that's all we need to know. I wish there was a way to like make a call in here. Is there? Or I wish there was a way to make a call in here and do the whole shebang. Let's see. Vision. Go to documentation. Let's see. About image analysis. Look at this. Detect objects, detect brands, describe an image. This is new. Detect faces. Generate a thumbnail. Oh, that's cool. Oh, because generating a thumbnail is gotta be harder than regular, because like what if it like, oh, I'm gonna make a thumbnail and you're like, okay, there it is. That's not a good thumbnail, friends. Area of interest. I guess they don't have the famous people thing anymore. Man, it was a fleeting moment of my fame. And now I'm not famous. Okay, let's go back over here. And what else we got? Image analysis. We did this one. This one did not work for us, remember, because it was still in preview. There is one question. Curious about how it creates thumbnails with multiple people in it. I don't know. I haven't tried it. Let's try this. Let's see if it'll block me again. Okay. See, look, it's like maybe hold off. You see all this stuff here? Maybe hold off. Okay. Okay. Oh, there's another one. Captions to image. I wonder. This one's probably blocked too. Yeah, because it's still in preview. Detect sensitive content and images. Browse for files. Is this AI telling me that I'm not sensitive? All right. Well, I'm not finding where to do the image analysis. Detect faces and images. This will just find my face, which is what we wanted to do, right? Which is kind of cool. It's like, it's basically Janice who's saying, Seth, it's because you're basic. You're basic. Okay. All right. So I'm going to stop doing this. And now it's time to get to our work. So let's do that. Let's get to work and do our... Hold on. It didn't work. I'm like, let's get to work. And then the thing didn't even play. Come on. Okay. Push this button and then this button. Let's get... All righty. Let's open up Visual Studio Code. Okay. So for those that do not remember, we are building an AI. Where is this running? Okay, cool. So we are doing an AI that detects rock, paper, scissors, rock, paper, scissors. Let me control plus this one. I don't know, do we like this? Or I think I like this better. It's like you can see better. Allons construire. C'est le français. C'est une langue magnifique, je pense. J'ai pris le français depuis 5 ans dans l'école, il y a longtemps. That's my French, for anyone that was wondering. Okay, so what I'm building is I'm using PyTorch Lightning. PyTorch Lightning to build an AI model that looks at pictures of me doing nothing, paper, rock. Look at that. I want to pound it, like rock to myself here. And then skizzers. And then we want to build a model to distinguish between them. So what I did is I upgraded my version of PyTorch Lightning. This one to version 1.7.2. It was on 1.6.2, and what happens is it broke everything. And so now we're gonna fix some of it. And you remember when I was in here, let's see. When I was in my Azure Machine Learning workspace, by the way, that's me and my wife. She's the best. You remember that my Rochambeau was having issues. And if you remember reason why, it was because it took a long time because once you set it up, it's like setting up GitHub Actions for the first time. That crap takes forever. And then once you get it to work, it's like it works every time. But remember, the message that we got was that I could not use this isn't the experiment. I think it was this one. The reason is because I was trying to use a V1 data set for V2 job. So what I went ahead and did is I fixed that. If we go to the data tab, you'll see that I have this experiments data source, and in there there's like folders. This is basically just mapped to a blob storage, one folder, and there's a ton of different kinds of data for experiments. So for example, was for earnings data. Let's see what's in there. Well, this is Azure Machine Learning. So it looks like this is earnings data. And then we have people data as well. This was for another experiment we're doing. These are all made up people. Look at these made up. These are made up millennial Twitter description of themselves. Music specialist, certified TV. Look, I built a library called Fibber.io or Fibber.io that generates like things, and so this is like hipster bio generator. This is so hipster. Like, I don't know who Skylar Conrad is, but he sounds like a millennial tool. It's not a real person, by the way. Like I made a data generator that I forgot I did. Like imagine if you described yourself as a hipster-friendly beer junkie, extreme coffee evangelist, social media enthusiast, and entrepreneur. Oh, I'm sorry. This is funnier than. Oh, here's a question. So it's fake data. So it's fake data generated by computers. Yes, I'll show you. But I mean, you don't have to. It's called Fibber.io. It's a library I wrote that I did not finish. I did it just so I could generate this data for programmers. All right, you can see here. This is you describe the task of the thing you want to generate, and then you give it distributions, and then it generates the data for you. So you can do that. Where's the? I haven't done it. I haven't done it in a while. Yeah, here it is. This is the code. Like I said, I wrote the whole thing like in a weekend because I had to generate data to do stuff for. You remember Minsu? She was on the show a couple of times. We generated fake data so that our machine learning model will be biased against dumb things like spaces versus tabs for programmers, because otherwise, like we didn't want the story to be, oh, Microsoft builds a racist AI model, because we would never do that on purpose. And so I built this thing. It's not all the way done yet. I mean, go look at it if you want, but I still need to, like, I use it. I put this thing in there. But basically, you give it a task description and then you give it an output and say how many things to generate, and it just does. And so this thing you see here is generated by a better version of this programmers.json. So it's test data programmers.json. Yeah, here's the task description. Let me control plus this thing. So basically it says use this full names.csv, load it up, and then every row is going to get a random first name and last name, an age that's normally distributed with the following mean and standard deviation, and then a discretely distributed location. And then these are conditional distributions that allow me to, force certain statistical properties for the data set. So, for example, the years of experience is a uniformly distributed thing for each one. Sorry, the style is discretely distributed, but based upon this, if you are tabs, your years of experience will be drawn from a uniform distribution. If you're spaces, it will be drawn from a normal distribution. And then there's another conditional on there that says if except, this is the name of the condition, if the range is between 5 and 10, then it's basically a uniform draw, flip a coin. If it's between 11 and 18, then we focus on the no. And then if it's anything greater than 18, then yeah. So basically, this describes the data that we generated for that thing that you just saw. And then let's see, what do we have in full names? Yeah, we just have full names. And then I think what I did is I found some like some random like little phrases, and I used like a uniform distribution to add these things. So that's why they all look really different, but you'll see repetitives like zombie specialist, unapologetic introvert. You can, if you look at it closely, you'll start to see that. But if you don't look too close, it looks good. So this is where that data comes from. The data that we're using is the Rochambeau data that I just showed you. Here's me just doing nothing. I think I showed you that one. Paper. And then scissors. Rock, paper, scissors. Right, there it is. And then what I had to do is I had to make a V2 data set. Remember, I kept trying to make it over in the portal, and that turned out to be wrong. So to describe the data set, you had to create this this YAML file. And this YAML file, and this is the cool thing that I did not know. I did not know, but now I do. Is we have these URI paths now in Azure Machine Learning that lets me like map to data stores. And that path that I just showed you is this path to rock, paper, scissors. And I basically I create a new data set, which is like a view into the data store called RPSN, which is rock, paper, scissors, new. And now if we go to this data, you'll see that I have a ton of data sets, but the newest one is this one. And you can see that this is the rock, paper, scissors, none data set. And if I explore it, you'll see that there is, it's kind of cool how it does this. And so I got this working. And then I ran the experiment again. We don't need this anymore. Let's go to the jobs here. Let's go to Rochambeau. I ran the experiment again once I did that. And then I started getting these other errors. Right? And it looks like, what is the user error? I didn't see... This is not helpful. Let me go to the outputs and logs, and let's find out what it ran. There we go. There we go. I started getting this kind of stuff, and I was like, oh, this is terrible. Basically, it feels like I was running a different version of, to me, it felt like I was running a different version of PyTorch Lightning in my code than I was in my container. And so I figured it's time to make these containers work together. How does one do that? Well, here's the environments that I created. And the custom environments, let me see. These are the PyTorch Lightning containers that I have. And this is on version 6. And you can see that I was clever enough to add a tag that told me the PL Python was 142, but as we saw earlier, I was messing around with 162, and then that broke locally, and so I'm like, all right, we're just gonna upgrade everything and make sure it works, right? Mario is having a really keen observation here. So many PyTorch versions. Yes. Welcome to the data scientist nightmare of having versions of a ton of different stuff, and it never is nice. And so I uploaded a data set, and I was like, you know what? I just need to create a new environment. And so that's where I left off. So what we're going to do today is we're going to split between creating environments, because creating an environment takes about 9 to 10 minutes once we get it to do the right thing. And that bothers me so much. So much. And so I thought I would use dev containers to test it out. And then once we did that, then I'd get back to the React. Why doesn't this other thing work? It's like this one doesn't, the delay doesn't work anymore. What is wrong with this button? Okay. Alrighty, so let's get to work. Let me show you this thing in motion because some of you are new and you probably want to see what this is doing. So there's the AI part, and then there's the web part. The web part you can find at rochambeau.ai. You can do that. Okay, so this is the how we do data. The data gets a path to this thingy, this data right here, and then it does a little transform on the images. It resizes them, center crops, and then zeroes them out. And then we do a little something transform this the tag into instead of like 0 1 2 3 none rock paper scissors, it'll be like 0 0 0 0 or 1 to be here. It'll be 1 here if it's this one, something like that. So it's like, I forget what it's called. And then I load the image set. I load the data set from the image folder, and this is a image folder. Basically, uses a generic data loader that uses the folder as the class, which is super nice. Super nice. I don't even have to think about it. And then I do a little split, 80-20 split, whatever is passed into the thing here. And then I use the training data loader and validation data loader, and I batch it according to what we're doing. I think I put 32 images in a batch. So that's the data loading. The second part is the model. This is the Rochambeau model. I'm using a Lightning module. The classes are passed in, of course, and I'm doing transfer learning over ResNet 18. For those who don't know, a ResNet 18 is basically like a deep learning model. Let's see if I have one output. Yeah, there's one. Let's reveal in File Explorer here, and let's open up this Onyx representation of the model. Holy cow, that's hideous. What is going on? Something's wrong with this. Do I need to update this? Is it gonna ask me to update? Wow, that's horrid. What is going on there? Oh, there we go. I think it just had a little hiccup. And so you'll see that this is just a standard ResNet 18. As it comes in, weights and biases, then max pool. You can see the skip layers on the ResNet. And then what I do is at the end, I do this little gem. I add this thing. And then I softmax the end here. And you can see that is right there. ResNet 18 to 1,000 to classes. Or maybe not. This doesn't look like that. Let's take a look. Let's take a look at that again. Wow, 1,000 to 512. I didn't do that. So 1,000 to 5. No, I see. So this is the output of. This is the end of the ResNet, and then this is me. These are in reverse, and then it goes 1,000 to 4, and softmax out to 1/4. You can see that's what I'm doing. Boop. This is a forward call. I call the ReLU, and then the softmax, a ReLU on the transfer layer. Get the X, and then I call the fully connected on the first dimension softmax. This is the computation. I call the model. I do a binary cross entropy loss, and then I get the accuracy. And then the training step is just I compute, then I log, and that's it. Using a stochastic gradient descent with a step LR, learning rate back off, which is nice. And then I save the model. And then finally, the trainer. The trainer is just a CLI, Rochambeau CLI, that inherits from Lightning CLI. After the model has fit, I get the best model. I load it from the checkpoint, and I save the model out, and I add some extra parameters. So let me show you what that looks like when it's running. So CD AI ls, and then let me get my system. No, that's not it. I want to show you my task manager, and here's my perf. mperf, and then I think we want to see the GPU working. Okay, so this is my GPU working. I'm using a NVIDIA 3080, and so we'll say Python trainer, trainer.py. We want to fit, and then the config is config.yaml, and the config.yaml just passes parameters in. Like, for example, we want to seed everything. These are the default outputs. Select the GPUs, do a logger, and then these are the things that we pass into those classes that I showed you, right? Like the batch size, whatever. And then here you can see some callbacks like early string model checkpoint and learning rate monitoring to do the learning rate back off. All right, let's do this. Now we are building our model. One would hope. By the way, this is Visual Studio Code, if you're wondering. Yeah, this ML Flow is behind. You can see here that the GPU is indeed available, and I'm using it. No TPUs, IPUs, or HPUs. This is a CUDA device, is 0. Our parameter base model is using a ResNet with 11.7 million parameters with a fully connected at 4K parameters, which makes sense. And you can see it'll just keep going until the loss doesn't improve by 10 to the minus fourth. And it's done in 18 epochs, and it's really fast because I'm using a GPU and the model has been saved. So if I go over here, you'll see that model was rewritten literally just now. The metadata file has some information about the model, like the classes, the model, the param size, and the timestamp of when it was created. And that's it. And the model is now different, but not really. The structure will look the same. But here it is. Here we go. Okay, so remember, you get to ask me any questions you want. No dumb questions, but I will have a lot of dumb answers. Oh, here's one statement. ReLU is like a filter. Kind of. It is. ReLU is a function that's actually not even differentiable, so it shouldn't even work. But it's a little hack. It's basically a line like this that cuts everything off that's less than 0. Strictly less than 0, which is interesting, right? So it is like a filter of numbers, but it's also a non-linearity that's introduced to increase the power of predictability. And there's a ton of activation functions. ReLU is an activation function. Tan-H is one. The hyperbolic tangent and softmax is another. Notice that there's a lot of ReLUs in here. It's because it's computationally easy to do. My last one, nonlinear non-zero, is what Abrar is telling you. What do you mean by that? Maybe if I said something wrong, I'll fix it. This one, I do a softmax at the end. This is a little bit more computationally intensive, but it makes the things look like percentages. So the answer is sum to 1. Okay. So let me show you the prediction part so you can see that. This is the scoring file that does the prediction. You can see that I have some test images here. So let's run this file. Let me debug it so you can see it. Are we at the breakpoint? Yes, we are. So the initialize, well, this is just logging everything. If the environment has an Azure ML model directory, this means that this is running in Azure ML, but it's not. So it's going to use a local, and it's going to resolve the outputs model. And notice that this is the dir. You can see that path right here. Let's move this over. It should have the fully qualified path. Why doesn't it? I don't like that it does that. So let's go to the debug console, and let's type out root dir. Doop. Notice that it's a Windows path for outputs.model, and it'll tell, oh, I'm like literally printing it out like a goober. I'm sitting here not doing it. So F10, we load up the meta.json. the file. Boom, boom. You can see that in the output. Oh, where's the output? I don't see it in the terminal, but it should be coming out somewhere. Oh, it's because it's logging in. You can see I opened the metadata. Oh, see, it's not finding it. Outputs model JSON. Oh, okay. So there's the score. Outputs model metadata.json. File not found. So outputs model. Let's do this. Let's do it again. We'll break right here. By the way, this is why I like Visual Studio Code. It's so nice to be able to debug. Oh yeah, Vadim is saying they're right. They're right. So Vadim is. Vadim, it's so good to see you, buddy. He is absolutely right. ReLU analytically is not differentiable because it's got a point at the 0, but numerical differentiation works just fine. It does. That's why it works. But Vadim, you and I know that mathematicians would be mad at us. He knows. Vadim knows that math people will be mad at us. And by the way, Vadim, it's so good to see you. Vadim and I used to be colleagues. Such a nice guy. Way smarter than me. Okay, let's see rootdir. Let's see what it looks like now. Projects Rochambeau outputs model. See, this is the problem. For some reason, it thinks that's why it needs to be AI model. So we'll stop this. Doop. Doop, 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 doop. Doop. Okay. Doop, doop. Rootdir. What do we got? Projects Rochambeau AI outputs model. Yes, that's the right thing. Now it's going to be happy. Boom. So model meta, you can see it has the classes. It loaded them up. Those are the classes. That's the model timestamp. I'm going to load up the model using Onyx. Oh, no. Oh, no. Onyx runtime is broken. Okay. This ORT build has TensorRT execution provider. CUDA execution provider enabled. Since ORT 1.9, you're required to explicitly set the provider's parameters when instantiating the inference session. For example, oh, I see. Since ORT 1.9, you are required to explicitly set. Oh, we got to ask Cassie about this. Providers, inference session. Oh, this is what makes it faster. So let's do this. We want to just do the CUDA execution provider because I don't think we have TensorRT. And no, we don't want no CPU. Psh, no CPU. AutoPep is not installed. Sure, why not? Put it in there. Put AutoPep in there. I want to be auto-pepped up. By the way, what you're seeing me do is basically what ML engineers do, right? The model's already done, and I'm just trying to get things to do the right thing for me. Okay, so now we can set the breakpoint here. I can take this breakpoint off, and let's do this again. Okay. Nice. So the session is loaded. I get the inputs. This tells me that the input to this thing is image. And the way you know this is the input. This is the prediction. And I named these things for me. There you go. Boom. Okay. So the model is been loaded. Then we do the standard transform for the image. Boom. And initialization is complete. We make a little function that does the inference. And then what this function does is inference. And it says, I'm predicting inference with this image. I run it. and we're gonna do the run. So I'm gonna go here to the run. This sorry, right here. This thing right here is just a schema to help. It's just a schema provider that says what this function is, so that the REST endpoint knows what it's doing. Okay, so let's keep going. We're gonna try with rock, and if you're wondering what this looks like, let's get this image here. Beep boop beep 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 beep. That's me doing the rock. Oh, over here. You know why I look so unhappy at this time? It's because I did not have a GitHub light up thing like I do now. It's okay, past Seth. You will get a GitHub lighted up thing soon. You'll be okay. All right. So I'm passing it that little image in, and so we'll F5 this, and it will start the inference clock. And then it says if the image starts with HTTP, which it does, it loads the image using requests. It opens the image as a series of bytes, and then it does the transform, and this now is a vector or a tensor. This is a tensor. What is it? It's like, hey, this took a long time. Yeah, it's a big picture. Pre-prediction. I do a run on the session. Boom. And then out comes this vector, right? And this vector is the output of the softmax. This thing right here. Oh, did I close it? Oh, you goober, you closed it. What were you doing? So it's the output of this last thing right here. And notice it's of size 4. And each slot tells you like which one it thinks it is. So let's go to it's Pred Onyx. So let's go to the debug console and print this out. So this is the interesting bit, because this is where people sometimes get confused. So let me open this up. So notice that these are the classes, and this class corresponds to this slot, right? This class corresponds to this slot. This corresponds to this slot, and this corresponds to that slot. The softmax forces these all to be equal to 1. So I'm going to say something that Vadim is going to like and not like. These are not actual probability measures. They are the outputs of the neural network. Outputs of the neural network forced to be summed to 1. So Yasmin is like, what are you doing? What is this? Oh, okay. I gave it this photo. I gave the AI this photo. I passed it into this function. And now this neural network is predicting if I'm doing rock, paper, or scissors. And not to give it away, 0 is none, 1 is paper, 2 is rock, 3 is scissors. And as you can see, it is guessing rock with confidence of 0.75. And you're thinking, well, that's like a 75%. No, I mean, it is, but it isn't. It isn't. It's not real statistics. My friend David Smith, who is an actual statistician, would agree with me. I should bring him on so we could all laugh at machine learning people, which I am. I laugh at myself all the time. Okay, so now when we go do that, we do the predictions complete. I take all of the classes and I put them into this predictions dictionary. Here's what this dictionary looks like. Do you see how I'm basically transposing the numbers that it used to predict? And again, this is rock. This is the largest one. So now the payload is this. The time it took, float 0. Why is it float 0? That's weird. It shouldn't be float 0. It should be the float of the total time. Well, we'll fix that later. I don't care. The prediction is the arg max of the classes, which in this case is going to be rock. These are the scores. This is the timestamp. This is the model. This is the model timestamp, and then this is the message. We stop the clock. Oh, here we go. I do put it in there. And then I put the time in there as that. And now you'll see the payload is this whole thing. Here, let's go over here and let's print out the payload. Payload. You can see the time that it took. 248. That's because I stopped it a lot. This is what it's predicting. It's predicting rock. These are the scores. This is the thing. And now we are done. And it does this. It's going to do this 4 times for all of them. And in the terminal, I don't know why it doesn't print it out here. It should print it out. Where does it print it out? Here, let me do CD. Oh, maybe it was here. No. Okay, let's do this. Let's do Python score, and then you'll see the outputs. But because it's... Oh, I know why it didn't work. I know why it didn't work. Because this runner ran it from the root thing, and that's why it didn't work. So now I put this back. And then we'll run it again. And then when you see it, you'll see that it's loading them all up. Very good. And I deleted that, so that's meant to be on purpose. So you can see it's a success. It predicts scissors when it's scissors. It predicts the other thing when the other thing, and that's that. Then the last thing you do is then you put it into an endpoint that you can call. This is the endpoint that I built, the Rochambeau endpoint, and this is the part where we need to automate it. And so now when I hit test, you'll see stuff like this. Rock. Oh, this is not a smart model. This is not a smart model. Paper. There you go. So this model needs some adjustment, which is what we were doing. We were updating it. Okay. All right. So that's the thing. This all works locally-ish. Now our goal is to get it to work in the cloud. So the thing that takes the longest to me, and this is the thing that has always bothered me about this stuff, is like I have to describe the environment inside of Azure ML. But environments, people know, take like 9 to 10 minutes to build. And it always so happens that I forget like one thing. And then I have to rebuild the environment, and it's just a pain in the rear. So I am fighting against that. I'm not going to do it that way. Instead, I created a dev container that has the Docker file that has everything in my requirements.txt. You know, I don't know why I don't have the requirements.txt in here. It's because I had it in here. I don't know. So I can move this over here. But that's my Docker file. And the cool thing about this is that this container I can describe as an environment in the cloud. But before I upload it and make sure it works, I can do this. Everybody, hold on to your butts. Hold on. What? I know. I'm going to do this. So I'm going to open this up, and let me do this. Let me change this so it rebuilds it for you. So Docker file, inference schema. Let me just, there, extra line. I'm going to open this up in the container. What? Let me rebuild it. Yeah. And there's not much change, so it just recognized it. So now what's happening is I'm running this in this Dockered container. Hold on, where's my here, let me get my Docker up. Boom. So now let's test it in there. Let's run the training in here. Bash. cd AI. Python trainer.py. Config dot YAML. Oh, I know what I forgot. Fit. Okay, so now we know this container works because I'm running in this container. So what I need to do is I need to move this environment up to the cloud. Up to the cloud. So we can stop this. We know this works. We got you. We got you, boo. We got you. Yes, keyword interrupt. And you can see this is cool. It's just running it in this Rochambeau AI container. And that's the container that I describe here. Right? There's the Docker file. There's the context. All right. So Azure ML environment v2. Let's see here. Here we go. Manage environments with CLI v2. Yeah. Okay. Create an environment from a Docker image. We don't have that. Create an environment from a Docker build context. We have that. So let's do this. Let's go into an AI and let's create our environments in the cloud. Let's see, cloud environments. See, we'll do here, new folder, train environment, and I'll take this Docker file, Control C, Control V, and this could be the Docker build context, right? And the cool thing about this is I won't need these dependencies anymore. So we'll delete this. And then this is the environment for deployment. So I'll have to have another deploy. So this one for sure will work for both, but I want to slim down the deployment one. And I don't need these dependencies anymore. I might keep these. No, let me just move them over here. There. And then we can get rid of these. Okay, so the environment for the did you see that? I got all scared. I was like, "What? This will be gone forever?" Oh. Yeah, I don't want that. So I'll just move it for now. Okay. So now this looks like it's the old schema. Oh, and this is to deploy. This is to deploy environment. We want the regular environment. So PyTorch Lightning. I did this version, and the version of this PyTorch Lightning pip show. Oh wait, I'm still in the container. I can get out of the container. Let me just close. I'm just going to declare tab bankruptcy. All of you go away. Cloud. Environment. Okay. Okay, cool. Version, and then we got to find the this we don't want because it's in the base. Okay, cool. And then we want to get the right this. We are using pip version 14772. And then what version of Torch are we using? Wow. PL version. PT version. Okay. Cool. I think this is the local one, though. I think this would be CUDA 11.1. Oh yeah, clear the banner. Sorry about that. Thank you. So this is where I'm gonna. So I'm gonna pull the label on there. Just leave it like that. So this is the PyTorch Lightning version, and this is the PT PyTorch version. Cool. I don't have this anymore or this, and the last version of the one we built was number 6. And look, we built this. Look, you see when we built this? It was time to clean up a little bit. You know what I'm saying? Mm. Okay, so it was time. This was old. Okay, so let's go back to this thing. I think you just need to give it the build context, and the build context is just a path. And the build context is going to be train. All right. And cool. So let's go back over here. PyTorch Lightning, indeed, in there. And this is the coolest part. You see this little magic button? Everyone's probably sitting here thinking, why is Seth going through all this trouble if he got the model to work, blah, blah. Because I want this to be repeatable. Because eventually I want Rochambeau to work for you so that when you create an account and it doesn't recognize you, you give it some images and then it builds a model for you. And I don't have to do anything, right? So now this is creating an environment. There you go. Version 7. And we should see here. Let's refresh this. Environments. Oh, there we go. Number 7. It's running. You can see the tags here. I should have put PyTorch Lightning and I spelled it wrong. Gosh, you doofus. You doofus. PyTorch! And I spelled lightning like I don't know what I'm doing. Psh, Seth. I mean, keep it together. Keep it together, Seth. And now I gotta bump the version if we do update it. Now, as we go in here, we're going to see. There you go. Looks much nicer. You're going to see the context is here. This is the Docker file. And then we can go to the build log and see that it's going to do it. It's going to build it. Right? Which is really cool. But this takes a couple of minutes. So I guess the next thing we want to do is we want to test the scoring. The scoring Docker file. Okay. So to do that, I let's open this here. But this is what all we needed. So these are the pip installs, right? So let's go back and see what we did here. And then I'll alt this. I needed IPY kernel? Oh, this was for... So yeah, I basically had it. But pandas too? I think the only difference then is... And this base image is different too. I wonder if it's just the same, right? because the only difference I have is I have Azure ML default. Let's take a look at how they do the PyTorch one. Let's go to environments here. Let's go to curate environments and let's take a look at the let's look at how they do PyTorch one. Oh, look, there it is. Let's look at PyTorch. I want to see what base image they use. What version of PyTorch? I'm using like 110, right? Yeah, that's what they're using. Why am I just not copying this? Huh. Interesting. I'm wondering if I shouldn't use this instead. To be fair, though, I know that container worked. So I mean, I don't need Torch audio and all that other stuff, right? I'm trying to make the inference container like as slim as possible, so we don't need that. I don't even need PyTorch Lightning. I don't need PyTorch Lightning. Oh, this is trained. Oops, I don't want to do anything with that. So let's close that. Like, I don't even use PyTorch Lightning on the training. Let's take a look. What do I use? I am using Torch Vision and Torch and inference schema. But there's no PyTorch Lightning at all. I mean, do you see PyTorch? I don't see PyTorch. Let's take that out. So we don't need this. Is this the we don't need this. We don't need this. I don't think we even use ML Flow. Pandas, I think we use. Inference schema is important. That's the thing. I don't need this. Or this. Or this. So this might be the slimmest I can make the Docker file. Oh, and then I gotta. Did I get the new container version? Nope, that was wrong. So let's go back to the container here. I'll just use this. Heck, I might even be able to use a slimmer base container. I don't know. All right, let's try this. No, same thing. Then what I'm going to do is I'm going to Control A this bad boy and put him in here. And then I'm going to reopen the container. In theory, score will work, but not much else. Rebuild. Let's take a look here. What do we got? Nice. Okay. It's rebuilding this. Oh, here's something from Mitsuru. We could have the same result using the Visual Studio Wizard, right? Though I love seeing it around. Yeah, I have not used Visual Studio in a long time. It's not that I don't like it. Oh man, look how big this container is just with PyTorch. I wish there was a slim version of PyTorch that just did the the transforms, because that's all I use it for. Because I use Onyx Runtime for I use the Onyx runtime for the inference side because that's huge. I mean, that's huge. It's 1.2 gig just for PyTorch. I mean, that container is going to be a beast. Okay, and so I can go back. Well, I gotta wait, right? Because it's running the container. So that's the thing about containers. There really is no wait. There's no way to not have the thing do that. It's just, it just is what it is, which is unfortunate. Because you gotta wait for it. Okay. All right, so I think it's almost done. This is building the container to do inference. And the idea is I should be able to run python score.py and it should work. And if we know that works in this container, it should work up in the cloud. If it doesn't, then I'm going to be frustrated. Absolutely frustrated. But yeah. And that's the cool thing about this is that I can try it out here locally and it won't take... This is still taking a long time. There's nothing we can do about containers and making things faster that way. I don't know. It just is what it is. Looks like it's almost done though. The other thing is I wish I could have start to code with multiple different environments too, I couldn't do that here. It was more of like a this one or that one. Okay, here we go. So this is I've seen this before. It goes away. Let's go to bash and let's do Python, or let's do cd AI python score.py. It works. Uh-oh. So it said incorrect padding, but it got everything else right. What was the incorrect padding one? Let me see here. Score.py. So for sure it didn't get the... I think maybe it was this. Bad URI. I think that's the one. Okay, this is good. This is good. So now I can do this. I can reopen folder locally. I don't need this deploy thing. Okay. Now I can do the environment for the GPU deploy. Is this deploy? I don't want to copy all of it. Let's just do this. PyTorch version. There is no PyTorch Lightning anymore. We're not even using PyTorch. Onyx runtime, and then we want to do there's like a pip show. What was the package we installed? Here it is. Cool. 1, 2, 1. So we'll go to the environment deploy. Oh, it's the same. It's the same as interesting. And this one would be deploy. And let's go over here and take a look at our environments here. Curated environments. There it is. GPU deploy. We're at version 3, so 4 is the right version. Nice. So let's run this. Let's see if this does it, because the reality is I'm tired of these environments not working, and we tried to do our due diligence. All right, let's go back here. Let's go back here to our environments refresh. You should see version 4 pop in there real soon. Yeah. There it is. It's running. Let's go back here. Let's take a look at our PyTorch Lightning here. We're on 7. Let's look at our build log. There it is. It's doing its thing. It's almost done. It's almost done. Okay, now that that's working, now we just need to get our job to work there. So let's go to our job.yaml here. There's the RPSN that I fixed to the new one. This is now going to be our PyTorch Lightning number 7 is the newest one. And this is the job. Nice. Yeah. Okay. Things are starting to feel... we haven't fixed the deployment yet. This is all going to be wrong. Job.yaml. Okay. I think this is almost ready to be tested. Let's just see if this is almost done here. It's pushing it. So we might be able to run this experiment again. All right. So for those that are wondering, I'm redoing my Rochambeau experiment, updating some of the frameworks, making it work locally, testing the containers locally, pushing the containers up to Azure Machine Learning as an environment, and then we're going to run the experiment. All right, my wife's looking at me. She's talking to her phone. What's going on? She's going to text me something soon. I feel it. All right, let's see. Is this done? You should be done. Oh my goodness, look at this. Let me read this to you. Let's see. Here it is. Here we go. What she just texted me. Hi, sweetie. Have you had lunch today? Would you like me to make you lunch? She's so nice. So nice. She talking to her lawyer. Oh, Jay. She talks to the lawyer on Mondays. Okay. Come on. This is the part that takes the longest and bothers me the most. Okay. The good news is that I don't have to wait to do the job. For the environment, because the environment exists and it's in there. So I'm going to submit this job now, and this should run everything in the cloud. See, Azure ML job create, and it's going to push. Oh shoot, we want to stop that. No. Okay, so we got to look at our AML ignore because it's not ignoring something. It shouldn't be 100 megabytes. Your file exceeds 100 megabytes. No. So we're ignoring PyCache. What is it that... Oh, maybe cert. We want it uploading our certs. We don't want anything in web. By the way, AML ignore overrides get ignore. Right. So let's try it. Let's try this job again, because that felt a little too much for me. We can kill you. Goodbye. Goodbye. Oh, we don't want this. Oh, yes, I don't want you. What file exceeds 100 megabytes? Your file exceeds 100 megabytes. What has changed? So we don't want PyCache for sure. We don't want the .dev container. We don't want the .vmv. We don't want cloud. We don't want data. We don't want ML runs. We don't want notebooks. We don't want outputs. We don't want the get ignore. We don't want the requirements.txt. We don't want the score.py. I wonder if the AML ignore thing went away in the new version. AML ignore. To rip files to be included in snapshot, create get ignore or AML ignore file in the directory and add the files to it. The AML uses patterns get ignore file. If both file exists, AML ignore takes precedence. I know. Yeah. Yo. I'm trying to understand. I'm trying to understand what. Like the code is up one directory, so it's only looking at the AI directory. That's all it's looking at. The AML ignore has the PyCache. Dev container isn't even there anymore because I moved it. The venv, the cloud, the data, the ML runs, the notebooks, the outputs, the get ignore, the requirements.txt, and the score.py. It should only really be putting up 3 files. That is so weird. Maybe there's some like secret file. I mean, reveal in File Explorer. Like it's only uploading this, and this. Literally 6 kilobytes. 6 kilobytes. I mean, what the heck? Six kilobytes. That's all it should be uploading. I wish there was like a only include these files. I wonder if there's a way to do that. That way we could like remove ambiguity. Did I spell .aml ignore wrong, or what's the deal? Rename. Yeah, I mean, it's in there. Yeah, I don't understand why it's unhappy. I wish there was an AML include, you know? Ugh. All right, I'm going to run it and see what it uploads, because this is weird. Oh, let's go look at the environment, by the way. Environments, PyTorch Lightning. It should be done. Dunzo. Yes. GPU deploy. This one will be building still, but it's almost done. Well done. Well done. This is fast. This is getting to be fast. And what's cool is notice that now there's like some what the heck? Maybe it's an error in what they're saying, because yeah. So it uploaded everything. Okay. So the job started. Let's go to the job and make sure it's got the right. Got the right things in there. Let's go to the files here. Code. Yeah, there it is. The four things I told you. Those are the four files. That's it. So it put those up there. Now it's running the job. So let's go to overview. It looks like it's queued in there. My compute resource that I'm using is this compute cluster called Gandalf. It's resizing from 0 to 1 node. It's a big machine. That's why I turn it off as often as I can. It's an NVIDIA. It has 4 NVIDIA Tesla V100s in there. And it costs $12 an hour. That's why I turn it off. This one will idle about 5 minutes before it shuts down. The other thing is this compute instance here, Saruman, turns off every day at 5 p.m. Doesn't matter what's happening. It'll just turn off. Which has burned me before. Okay. So let's go to jobs here. Rochambeau should have a queued job. These ugly ones we can get rid of. Let's delete those ones. Jess. And let's add a column here to see when it was created on. And then we'll move this up. Here. Below one. Save. So you can see like these I've done for a very long time. You can see the charts of these things. So looks like VGG19 is the one I did the most. These are all the architectures I tried. Nice. Oh, it's running. Let's save the view because I just made a change to the view. Let's go to this. Let's go to the outputs and logs here. Looks like it's executing now. It's pulling the container. Fingers crossed. Fingers crossed. Oh, let me control plus this because it's a little tiny. Right. Looks like it's got the container. Already existed. Wonderful. Refresh. Now what it's doing is it's preparing the sidecar to the job. So this is what it does on its own, right? There's the log, sidecar logs. There's everything nice. Everything's prepping. And then if it goes well, you'll see the 70. It goes 55, 65, 70. And it's the 70 that has the output of the actual job. These are the metrics that come out. Overview. Nice. Command job. There's the data. The new one. Looks like it's doing the thing. Refresh. Here we go. We're making things work. Oh, come on. Yeah, looks like everything's going according to plan. This is actually taking longer than the ones that broke are taking, which is fantastic. It means that it's working. Why does this have such a large... let's move this over here so we can see it all in one place. There you go. So refresh. No, we'll save the view. Save. Let's go to the outputs and logs. We should see the new one soon. Yeah, it's all about waiting. So we'll close this. What's cool though is you can see in the code that we've only uploaded exactly what we wanted to run the job. And we've tied it exactly to the environment that we built for this purpose, right? And it's all been pretty fast, actually. Oh, shoot. It's time for our walk-off music. Because we are almost done with the show. Man, we have spent a lot of time. Oh, no. Oh, no. Oh, no. What's the problem? Let's see. Job failed with non-zero exit code. All right, let's take a look. Here it is. What? What's the problem? What? Uh-huh. I know what this is. I need to add the ML Flow Azure ML. This one. I need to have this on there. Oh, a bummer. Bummer. Well, my friends, it's been a privilege being with you. I know exactly how to fix this. I'll fix this for us by the next time. Basically, the training environment needs to have this in the Docker file. And that's it. So we're going to go to version 9. And we're going to push this up. Man, it was almost there. It's been a fun time being with you, my friends. Next time, September 9th, I'm going to be out of town. I'm going to be in the UK. So if anyone's in the UK and wants to meet up, let me know. For a wedding. How cool is that? Huh? For a wedding? Next time, Cassie is going to be taking over for us. She has got a bunch of guests. September 9th at 11 a.m. Pacific time, the latest from Azure Form Recognizer with Vinod. I did the interview. She's going to play that, and then hopefully Vinod will be there to answer any questions. At noon Pacific, Deep Learning Container with PyTorch and AML, parts 1 and 2, with my good friends, Paranita and Jessica. So make sure you tune into those. It's going to be a hoot. Does your wife? This is Jay, man. Does your wife know you're getting married in the UK? No, her cousin is getting married. But it's been a privilege being with every single one of you. Thank you so much for watching, and hopefully we'll see you live at the next one. It's been a privilege. Take care, my friends.